let's get started and meet our first special guest, Dr. Werner Vogels, CTO at Amazon.com. Dr. Werner Vogels is the Chief Technology Officer at Amazon, where he is responsible for driving the company customer-centric technology vision. As one of the first behind Amazon approach to cloud computing, he is passionate about helping young business to reach global scale, transforming enterprise into fast-moving digital organizations. Mr. Vogels joined Amazon in 2004 from Cornell University, where he was distributed system researcher. He has held technology leadership position in companies that handle the transformation of academic technology into industry. Mr. Vogels holds a PhD from Virgin University in Amsterdam and has authored many articles on distributed system technologies for enterprise computing. So please welcome Dr. Werner Vogels. Hi,
Thank you,
Werner. How are you?
Dimitri. Very well. Thank you. Thanks for having me.
That's awesome for us, and we're honored to have you at our conference. And I would like to talk with you about, some revolutions in cloud computing, and the first one actually related to uh, your future vision. And AWS was a pioneer in when it first launched in 2006, right? And you made a lot of revolutions actually with virtual machines as a service or key-value storages, and you provide a great features for quick up and run our applications like Beanstalk, then containerization to support microservices, finally serverless. So could you please share with us some insights or I don't know, some your thoughts? What is your next revolution?
Um, it's hard to predict revolutions, of course. Yeah, that at first. Um, yeah, I think the days of infrastructure as a service, where AWS purely was focused on compute storage, databases, security, networking. I think those days are long gone. 2009 maybe. That's sort of the state of
Mhm.
cloud computing at that moment. We're now 16 years into this, and I think one of the things that clearly is different from the early days is that we now have well over 250 different services. Yeah, and that has actually been by design. Yeah, I always thought that if you would, in the past, infrastructure providers or software providers would come to you with everything in the kitchen sink, basically all packaged together with partners, documentation, whatever. And in essence, if they would deliver this new platform to you, they had already been designing that for the past 5 to 10 years. So in essence, you get new technology, but it's 5 years old. And
Yeah.
one of the things that I knew that was going to happen with cloud was that development was going to be radically different. But we didn't know how. We had an inkling because if we would even give all these smaller components to you, you could really pick and choose, and we could sort of quickly adapt to how, let's say, development in 2025 or 2030 was supposed to happen if you have these smaller building blocks. Now, with 250 of them, for us lower level techs, we love this kind of stuff. We can stitch things together, do stuff. Many of our customers, however, especially in the enterprise space, would like to see more solutions. Yeah, they want a backup solution. They want a disaster recovery solution. Yeah, or for example, you can create your own data lake. You use S3, you use Glue, you use database migration service, Kinesis, Athena. Put the whole thing together. We love doing that kind of stuff. Most customers just want a data lake. Yeah, and so with data lake formation service, we actually can sort of pull all these pieces together using best practices, integrating lineage tracking, security, all these kind of things. And so one of the directions that you'll see AWS take will be to make these things easier, to make stitching all these different components into sort of a solution easier for you. And not just us, of course, this is also the work where many of our partners are working in. It's not just that AWS provides a backup solution. There's many other companies that actually do the same thing on top of AWS. So making it easier is definitely one direction. The other one is more vertical solutions. Yeah, if you think about sort of solutions for oil and gas or for life sciences or e-commerce or whatever, people would like to see unique solutions built for that. And again, we do this together with partners, some of it with AWS, but it's clearly sort of a direction away, a level away from all these little smaller components that you can stitch together. Now, I do think that we are going to do a lot of things in those smaller, in the infrastructure part as well. And I think if you look at sort of the early days of cloud, we basically had 2 or 3 of these let's say, regions. Yeah, US East, Dublin, I think either Tokyo or Singapore was the first one in Asia. Now, 27 regions around the world, 9 more coming. And not just, so now the time when you thought that cloud was something out there in a big set of data centers is long gone, of course. And then you got CloudFront, and you got Lambda at the edge. Now we have local zones, yeah, where basically it's a mini zone that connects back to a big zone for low latency, whether that's for gaming or for music or collaboration and things like that. And then you get outposts, yeah, basically a piece of AWS cloud in your own data center that makes it easier to sort of do migrations and or start developing for AWS, but you still need to connect back to your SAP system on premise. And then even further to the edge, we have a wavelength edge, where, if you build low latency applications on 5G, you want to connect direct to that. And then, of course, next stop is space. If you don't even see the recent photograph, I can't show it here, but, one of the snow cones in the International Space Station. And the interesting thing is not that we transported it there, it's the certification you have to go through to actually be able to move a device into the International Space Station and still have it work. So that's what I would call the everywhere cloud. You can imagine that the cloud gets closer and closer to you, where I think we are moving towards an ambient computing world where we actually no longer know what is digital and what is physical. Yeah, we already seen that with the voice assistants like Alexa and others, where the devices actually can't do much. It all lives in the cloud. Yeah, the Echo devices, you have a microphone, you have a speaker, and a hardware lock button. That's all it can do. All the capabilities live in the cloud. And as such, a digital world sort of merges. And for that, we need to get things closer to customers. And whether that is through IoT or other pieces, things get closer to customers. And of course, I also think that, so first of all, I think that one of the biggest challenges that we face at this moment in our IT world is the lack of engineers. I was just in Germany, and they mentioned 80,000 open IT positions in Germany alone. So for that, we need to make software development easier. Yeah, so on one hand, we need to support our current developers with great tools, of course. We'll also take away lots of the heavy lifting so they can focus on actually be more productive. One of the biggest gains of cloud computing has always been to make developers more productive. To not have to actually not even do the cables, but don't have to think about hardware anymore. Now, can we level that up? Yeah, make many of the tasks that we do either as operations people or as developers or in the DevOps world, what can we make it easier? And I think for that you need to learn from others. And the best way to learn from others is to use machine learning. Yeah, and so what you've already seen in AWS is with DevOps Guru, help you actually looking for particular patterns in your log files and alarming. And so basically, taking away the grunt work from what you have to do if you when a DevOps org. Or with Code Guru, actually taking away sort of helping you in an easier way with code reviews. Or let's say profilers and things like that. And I don't know if you guys seen the announcement, was it last week or earlier this week at Remars, Code Whisperer is a new service by AWS that helps you actually sort of based on basically millions and millions and millions of lines of code out there, together with best practices from AWS, allow you to sort of describe things in natural language, and then you get a piece of code to actually do that for you. So making you more productive. However, in all of that, it comes with other responsibilities. Let's put it that we need to make sure that the code that we do generate for you is secure. Yeah, or we need to be able to give you references back, telling you, oh, wait, this piece of code came from, this particular open source project that we've reviewed. And also with that comes, as always, if you base things on machine learning, is there a bias into sort of the models that we've created? And can you do bias tracking through this, or indicating where we think, this code that we've gotten out of this particular repository may actually be sort of whether it's gender or other issues related, that we can sort of indicate that to the developers.
The latency is a huge problem for before and even right now, right? And cloud everywhere, it's a really great concept. And also machine learning, and they really help, because I'm architect, and I'm always trying to find tool set which can help me to evaluate somehow the security problems in cloud, etc., to make some audit for the customers. And currently AWS provides a really great tool set which quickly can show the problematic with performance, billing stuff, scalability, etc. So it's really great tool set. And of course, low code, no code, which can help developers to be more productive. It's probably our new way how we should develop our solution in future. All right, so we'll talk a little bit about what will be your next vision, right? But at reEvent 2012, you were talking with Jeff Bezos about future and what will not change in next 10 years. And now, as you understand, 10 years already passed, and I would want to ask you what is not going to change in next 10 years, and in cloud computing, and around what solutions we should build our architecture and businesses.
Well, there's different points, of course. I mean, what's not going to change is different for every business. What Jeff referred to was how to build flywheels. Flywheels are things where you continue to put energy into, and it will continue to run and help you forever. Now, in retail, and that's easier to see how that works. It's size of your catalog. The larger your catalog is, the higher the likelihood is that customers can find what they're looking for. Yeah, it's not something that you put out a press release about. Yeah, it's something that sort of immediately starts driving more business. And of course, the other thing, convenience in retail places. The faster, the more predictable you can deliver your packages, the more customers are going to be happy, the more they're going to use your service. And of course, lower cost. Nobody's going to say, oh, I love Amazon in 10 years. I love Amazon. I wish they were more expensive. Yeah, it's not going to happen. And so if I think about AWS, I think there's a number of these other things that are under the covers where you don't do press releases about, sort of, that are fundamental properties of the cloud. Number one is security. Security, I think consistent performance, scale, reliability, sustainability these days, and cost. Any innovation we do in those particular areas are probably things you're not going to put press releases about, but they will benefit your customers forever. The more energy you put in those. Yeah, so take consistent performance. In definitely during the earlier phase, when we were using virtual machines, on a traditional, let's say, Linux-based hypervisor, at some moment, if you have multiple of these virtual machines, they all have to fight for the hardware through the DOM0. And then you get something called virtualization tax. Yeah, on one hand, the performance drops. The other hand, you see, for example, on the network, significant jitter. And so we innovated in that space by starting building a system called Nitro, which basically offloads many of these tasks, and we could build a onto separate hardware, and we could build a minimized hypervisor. Because one of the things with the DOM0 based on Linux is that your attack surface is complete because it's a complete kernel, basically. By actually doing innovation and driving in towards Nitro, we were able, for example, one of the first things we did was that virtual machines no longer had to fight for access to the hardware. They would get fair access to it. So while in the earlier days, customers would see significant jitter on the network if they would try to really pump things over the network, after the move to Nitro, consistent was just performance. Performance was just consistent on the network and predictable. Now, it doesn't necessarily need to be the fastest, but it needs to be predictable. Now, you don't put a press release out about that. All these things you do under the covers to be able to sort of help customers make things more predictable are a flywheel. The same is, I think, most of the things that are, there's this interesting sort of play together between efficiency and sustainability. If we can help you drive your costs down by becoming more efficient, it's most likely that you're using less resources as well. And so most of the innovations we've done in our data centers, for example, around power distribution, no longer having massive centralized UPSs, but small batteries on each of the racks. All these things, or about sort of good water management, and all these things help drive the cost of the data centers down, become more predictable, which we can then give back to our customers. But at the same time, they serve a sustainability goal. Yeah, and I think that's these days is very important because more and more of our customers would like to know about sort of the impact of their architectures on, let's say, carbon footprint and things like that. So anything you do under the covers there, without building new services on top, are going to help our customers forever. So I think our flywheels under the covers of AWS are indeed, any ounce we put into security will benefit our customers forever. Indeed, performance, scale, reliability, cost, and sustainability, I think, are sort of the drivers of under the covers flywheel, the way that Jeff talked about that at our first re:Invent.
Awesome. Yeah, so pricing model will stay stable, I would say, right?
Well, we drive costs down.
Performance.
We continue to hand back any of the efficiencies that we achieve in data centers, for example, or in better negotiations with networking, or we've built our own networks by now across the world. And there's such a better control over your costs. You can drive your costs down. And as always, we're handing these cost savings back to our customers by lowering pricing.
That's right. Yeah, performance predictability is really important. Security, all SLAs you provide actually should be stable, right, for your customers. And you mentioned about sustainability, and I am a huge fan of well architecture framework. I think this great book which you published a few years ago with reference architecture, some good practices we should follow, right, to achieve that quality attributes mentioned in that. And the 6 pillars just recently added, right, to well architecture framework. You mentioned sustainability. How we should deal with that right now? So, what should be our mindset to build architecture to contribute sustainability?
Okay, so I think there's a few different points there. First of all, just moving applications out of your own data centers into the cloud already gives you this massive benefit. Yeah, I mean, if you talk to many of our enterprise customers, they're really proud if they get a utilization of their own data centers between 15 and 20%. Yeah, I mean, I often compare that to, most of us have a car. Yeah, and so you drive to work, you come back home, and you don't use the car actually that terribly much. And there's all these ride sharing options and things like that. But imagine you would bring a car home and it would need to keep being idle in your driveway. It will be basically use energy even if you don't use it. Well, that's sort of the state of corporate data centers. Yeah,
Mm-hmm.
80% or 85% of the energy you pump through it doesn't serve any workload. So just by moving your applications over to the cloud, where we can actually manage sort of optimization of placement of your workloads on virtual machines and on the hardware, I think some of the current numbers are immediately you reduce your carbon footprint by 80%. And it has to do a bit with, so I think there is in sustainability, there's also this shared responsibility model, a bit like we have with security. Yeah, AWS is responsible for security in the cloud, off the cloud. Customers are responsible for their own security in the cloud by using the right tools that we give them. So the same goes for sustainability. You know, we are responsible for making our data centers and our technologies as sustainable as possible. Yeah, we are at this moment the largest corporate purchaser of renewable energy in the world. And I think at the moment we run at about 15 or 16 gigawatts. We have 310 different renewable energy programs running around the world. And we do a lot of innovation there as well. It's not, for example, we have this, I think it's a solar farm just outside of in Texas, and it's a 300 megawatt facility, but we also invest in a 150 megawatt facility to store the energy for off-peak usage. Yeah, after all, there's this moment during the day when the sun is not there, but you still need electricity. And there's a lot of innovation going on there. And so it's all part of what we call the climate pledge, where we've pledged that by 2030, we should be completely on renewable energy. I think in AWS, we're probably going to achieve that in 2025 already, where we are completely on renewable energy. And then all the innovations in the data centers, good water management, all these kind of things, what you can expect of us. Yeah? Then we need to give you, and that's what we try to do with the well-architected framework, advice on how you as an architect should think about what are the right tools and mechanisms to use. Yeah, for example, on the watch, if you move to ARM, if you move to the Graviton processors, now it's not only that you see this, was it 34% or whatever in price performance reduction, yeah, same performance, lower cost. You also see at that moment a similar reduction in energy usage. And so, how to really architect your system, how to make it scale up, and most importantly, scale down under which conditions. If you use serverless technologies, it even becomes easier for us to do the placement. Yeah, the same goes for if you use containers. If you run over Fargate, Fargate can optimize the placement of your container images to really help you minimize your energy usage. And so there's all these different components there where we give advice to architects if this is what you would like to see. Now, then there are a few others, and I actually think there's a layer on top of that still where, we, after all, in AWS cater to software developers, builders, who in general build applications again for their customers. So there's another customer layer on top of that.
Mm-hmm.
I think one of the things that you have to start thinking about as an architect is how much carbon do I actually want to spend for this particular component? Now, imagine, let's go back to retail. Imagine on the Amazon site, you have this bestseller list on the site. Yeah. Does that need to be, how highly available does that need to be?
Mm-hmm.
Yeah. Do all the components of that e-commerce site require the same high availability? Yeah, do I need to do active replication over multiple AZs? Or maybe can I think like, you know what, if the bestsellers are offline for 5 minutes, that's not such a big deal. Let's just do a failover. and maybe that's that for some components, your scale and reliability may be very different, maybe have different requirements. You can make different choices. Yeah, and in general, again, fortunately, efficiency and cost and sustainability go hand in hand there. But it needs to be a business decision whether or not how highly available or how much you have replicated this component, or whether you can just make use of some disaster recovery strategy instead. But also, I think we, in general, as humans, have become addicted to high imageries on our web pages, and we want to stream our Netflix or Prime Video at 8K.
Yeah.
Really? Really? Do you know
On
how much that
smartphone.
costs? Do you know how much that costs you, and in terms of carbon footprint? So I think it's not just, I mean, on one hand, we need to service the cost of compute and storage and databases and choices. For example, you can make use of most of the databases, most services we have in a serverless fashion. Yeah, we can make AWS can optimize that then for you and reduce your carbon footprint. But towards one level up, towards your customers again, do we really need to have this high level of imagery on each page? Do we really need to stream in 8K, or can we just be? Because to be honest, if I stream it over the internet, the difference between Full HD and 4K and 8K is suspect. Yeah.
Right.
Again, we need to start thinking. Either we need to start servicing the cost of these things in terms of carbon footprint to the end user, and maybe as engineers, we should start thinking about where do we build in knobs such that we can start turning them and see what is the best for our company. For example, there's this long-standing sort of good knowledge that reducing latency for commerce operation will improve conversion. Yeah, and so, but there is a point of diminishing return. Let's say there's your median latency is 1.2 seconds. Yeah, but you know how much it costs to actually achieve that. How much more compute you need to do, how much different network you need to do. And what if you actually bring it back to 1.4 seconds? You may be using less energy. You may actually lose maybe a little bit of your conversion, but that might be a cost you're willing to take in exchange for being a better, let's say, sustainability customer. And so there's lots of things I think that in the future at the architecture, as well as at sort of product development level, we are going to see happening. Because it's not just sufficient to know how much carbon this particular compute is using, but then what do we do with that? How should it influence both our architectures as well as the way that we engage our customers?
Yeah, that's first of all. Right now, I know how to pitch AWS migration from on-prem to AWS to save the world. That's a great sentence.
No, and I'm
Also,
actually serious about that.
yeah, I
Remember
understand.
that of the total IT, cloud computing, I think has still only something between 10 and 15% of the overall IT spend in the world. There's a lot of work still to be done for us to really drive sustainability to a much more important issue within IT.
That's great. Yeah, and yeah, it looks like win-win solution for anyone. We will save costs for the business, right? And in this case, with this saving cost, we're saving some electricity and other resources, right? So
Yeah,
looks like a good strategy. All right.
absolutely.
So
And then
and
also, so as an example of this, my blog, All Things Distributed, I had rewritten it with lots of cool imagery and things like that. That looked really attractive. But I kept looking at it and think like, this is nonsense. One of these video servicing companies, their homepage is 35 megabytes. There's something wrong at that particular point. Some of my blogs were sort of, and it's only text. Remember, 5,000 words or something like that, were a few megabytes. that doesn't ring well. So I rewrote the blog to be minimal. I still have a nice image and things like that, but the images are no longer, let's say, the 4K or 8K imagery that you would need. You still get the message across. So after all, it's about the content, not necessarily about how we dress it up.
Yeah. Yeah. Use more text than images. Yeah. Valuable text. Yeah. All right. Probably the last question. Actually, you mentioned that there are a lot of services which can help actually to achieve sustainability, like serverless, etc. And right now, you also mentioned that you have uh, 250 AWS services right now, right? And the question from community, for any experts who would like to pass the certification, it's quite too hard to remember all of them. For example, for architects should understand on high level, but should understand the whole scope, the whole borders of the services, right? How to build the solution. So they should somehow to deep dive a little bit in each service and understand the some specification of the services. And this is the topic: primitives versus solutions of frameworks you already mentioned. So how you will deal with that? So you will continue with primitives, or probably you will provide more and more solutions like frameworks in future?
Yeah, well, if you relate that back to trading, yes. Don't you think that I know all the 250 different services? Yeah. It happens now and then that I think like, wait, what is that? Yeah. And so I do think having a good sense of sort of cloud native development is important for every engineer. Yeah, even if you don't use the lowest level services, still having a good fundamental knowledge of them is I think important. But then if you look at sort of the pieces on top of this, if you're not going to work in IoT, skip the certification for that or mobile development. Yeah. No, and so there's many of these pieces that are already relatively vertically oriented. Yeah.
Mhm.
I think you need to have an understanding of all the custom databases that we have, such that you know which one to pick, but you don't necessarily need to be an expert in each and every one of them. Now, I do think that, at the minimum, you need to have a good understanding of Aurora and DynamoDB, because I think those are sort of the real heavy hitters still. But then, whether it's Neptune or QLDB or any of the others, you may start to dive into those once you have figured out, oh, you know what, there's a graph problem here. Now we need to start learning about Neptune. And so the same goes for some of these other areas. I do think, looking towards the future, that every engineer should have at least a fundamental knowledge of how to use machine learning. I think our systems are generating more and more data. These data, and whether that is even our log files, it's not necessarily application data, or it may be system related data. And so these data sets are only growing and growing. And the time that we could just type in a SQL query to find what we were looking for meant that we already knew what we were looking for. And so, for example, you may sit on, take Amazon Retail again as an example. Amazon Retail sit literally on billions and billions of orders over the past 25 years plus. Yeah. And we know exactly which ones of those were fraudulent and which one were not. And you can use you can build a big machine learning model out of that, and you can then, when a new order comes in, have a score about what the likelihood is that this is an order that is also fraudulent. But these fraudulent patterns change over time. What was fraudulent, let's say, 5 years ago, bad actors move as fast as well. So you continuously need to look for these newer patterns. You can no longer do that as a single engineer by typing a query. Yeah, because that sits in your head. You need to automate these kind of things. And so I think that every engineer should start to have a fundamental understanding of where they could apply machine learning, what kind of the capabilities and the limitations are of machine learning. Because I
Mhm.
do think this will be a fundamental part of almost every engineer's job. And so at that point, I think sort of SageMaker becomes important if you really want to dive into that. But then also, there's many cases where you just want to have a pre-trained model. If you're working on a medical application and you want to make use of comprehend medical, that to actually extract data from these traditional documents in your hospital, uh, instead of doing that by hand or developing something for yourself, we have pre-trained models for those kind of things. So knowing which those different models are and how to use them is a good thing to know, because I think those things will help you become more productive over time. So I do think next to fundamental understanding of sort of cloud native computing, machine learning definitely is an area, and we're putting a lot of effort into that with lots of training. And whether you kind of toys with play around with, Deep Racer or some of the other devices that we've built to sort of experiment with. We have Machine Learning University. All these kind of things help you sort of become knowledgeable about machine learning. And I think that's sort of one of the things that would advise every engineer to start looking at. Sort of what do we do with all the data that we generate? How can we be responsible in using that? And what are the best tools for that?
That's a great advice for all our communities. So what they should learn, yeah, tomorrow actually. Yeah, that's great discussion. Thank you for your time and to support our conference. It's really important for Ukraine and all our community. Thank you again, and have a nice
Absolutely. And,
day.
and be safe out there. All our customers in the Ukraine that make use of AWS, we're happy to continue to support you, whatever we can do, both on the humanitarian side as well as on the technology side. So, be strong.
Thank you. Thank you. We will.